Good afternoon. My name is Lisa Garcia Bedoya, and I serve as Vice Provost for Graduate Studies and Dean of the Graduate Division here at Berkeley. It is my sincere pleasure to welcome you to our 2023 Berkeley Grad Slam competition. Today's event comes on the heels of Graduate and Professional Student Appreciation Week, a week that seeks to emphasize the contributions, impact, and value of graduate and professional students on campuses throughout the United States. What could be more fitting than to round out that week with Grad Slam, an opportunity to celebrate and make visible the outstanding research done by our graduate students. Grad Slam was launched 9 years ago by former University of California President Janet Napolitano, with the goal of sharpening graduate student communication skills and providing an opportunity for the public to learn more about the research being undertaken by graduate students at the 10 UC campuses. This program also enables us to demonstrate our commitment to access in that it asks graduate students to present their research in jargon-free language. Especially as a public university, it is our Appreciation Week, a week that seeks to emphasize the contributions that is accessible to a general audience and not just to academic specialists. Here is how the UC-wide Grad Slam competition works. Each of the 10 campuses conducts its own campus-wide competition and selects a finalist to compete in the system-wide event, which will be hosted this year by University of California President Michael Drake on May 5th. That competition will be live streamed, and we hope that you will all log on and join us again to cheer on the 10 UC finalists. Here's the process we use at Berkeley to determine who our campus finalist will be. A faculty subcommittee of the Graduate Council reviewed videos submitted by graduate students from a range of disciplines and selected the 7 semifinalists whose presentations you will hear today. Let me take this opportunity to thank the members of the Advisory Committee for Graduate Student and Postdoctoral Scholar Professional Development for all their hard work. We know there were many worthy submissions and congratulate our 7 finalists. Today's presentations have been evaluated by a distinguished panel of judges. I would like to take a moment to thank each of them. Wendy Takuda, award-winning TV journalist, speech coach, media consultant, author, speaker, and naturalist. Eric Stern, Senior Vice President of Capital International Investors, and also the chair of the Graduate Division's Executive Advisory Committee. Fiona Doyle, Distinguished Professor Emerita of Material Science and Engineering, former Vice Provost for Graduate Studies and Dean of the Graduate Division. And finally, Justin Lee, the 2022 Berkeley and UC system-wide Grad Slam champion, who is a PhD candidate in metabolic biology. Our heartfelt thanks to each of you for volunteering your time for this event. In addition to the panel of judges, several years ago, we introduced a new feature to the competition. You, our audience, will also be judges. You will be invited later in the program to select a People's Choice winner. More about that later. Now, I am very pleased to introduce to you our keynote speaker, Justin Lee, who, as I just mentioned, is a PhD candidate in metabolic biology here at Berkeley. Not only was Justin last year's campus Grad Slam champion, he also took home first place in last year's UC system-wide competition. Knowing that he would be unavailable today, Justin kindly recorded a message for us to share his reflections on the value of the Grad Slam program.
Hello, everyone far and wide. First off, thank you to GradDiv and the Grad Slam team for having me back and giving me the space to reflect on my Grad Slam experience. My decision to come to grad school was driven by passion. Like many others, I was enamored about the world around us and wanted to develop unique skills and traits that would help make a contribution. Our passion for research to change our global communities is what unites us as graduate students, no matter what field you work in. We've worked to become dedicated experts in our fields by strengthening the fundamental building blocks that is laying the foundation for a new home of knowledge and innovation. What we sometimes can forget with graduate school immersion is the big, bright, and curious existence of the world around us. Participating in Grad Slam last year broadened my perspective on all the ideas and innovations happening here at Berkeley and in the UC system and renewed a curiosity for the dynamically changing world culture around us. They're students pioneering the emergence of machine learning for modeling complex systems. Other students are leading the charge in understanding and building networks and support in times of socio-political reckonings and crises. Scientific advances are being made in the labs to understand and better our health and our planet's environment. And others who are literally doing out of this world research in understanding the galaxy system we exist in. Grad Slam challenged me to evaluate the accessibility of my research work, not only to my immediate scientific community, but to the global community at large. What good is having the solution to world peace if you're not able to share how it works? As many others who have participated in the Grad Slam prep process will attribute, less is more. The real challenge is eliminating the jargon and making our work understandable to a broad and diverse-minded audience that allows us to engage in meaningful conversations, engaging dialogues, and cross-field collaborations. What can be so hard is letting go and simplifying a body of work that we spent years and years developing. Figuratively, it's like cutting off the arms and legs of our extensive body of work we've raised just to be left with the heart of it to show. For those of you in the audience who want to understand the challenge of condensing our passion, try describing your favorite pizza order without using the menu words or ingredient names. Trust me, it's not so easy to describe that circular doughy baked good with that red sauce and melty stuff on top. The benefits of distilling our work to a Reader's Digest version in the length of time of waiting for your coffee order is more than you realize. You never know who's watching, whether that be someone who is unrelated to your field and has resources to collaborate and elevate your project, or an undergraduate who's found interest and inspired to contribute to your work or field. Since Grad Slam, I've been exposed to new resources and network connections I would never have had access, all because I was able to connect with an enthusiastic audience. It has reframed how I think about science and added a new dimension of thought to my work and research considerations. I am so excited for everyone to hear from our diverse field of graduate student presenters today. Even though there is a competition, at its core, Grad Slam is a showcase celebration of years and years of asking questions, testing solutions, and hard work. We are tackling big challenges and are the players for enacting real change to shape the world as we want it to be. To our Grad Slammers, thank you for finding the voice and courage to share your story and give us a glimpse into your academic homes you've worked so hard to build.
Thank you, Justin. In a minute, we will begin the presentations. But first, a word about the order of the speakers. Rather than the usual last name alphabetical order, in an effort toward greater fairness, we have randomized the selection. For the Grad Slam competition, each contestant has 3 minutes to present their research. According to the guidelines used in all Grad Slam competitions, presentations are judged on their intellectual significance, appropriateness, clarity, organization, engagement, delivery, and visuals. Points are deducted for every 3 seconds that the presenters exceed the 3-minute time maximum. In preparation for today's event, we had each contestant pre-record their presentation. Please note that the contestants were prohibited from editing their videos after they were recorded. Our contestants also are here with us live in the studio. So after each presentation, I will be asking each student 1 or 2 informal questions so that we can get to know them better and hear about how they came to their research area and what their future plans are. After all 7 presentations, you will be invited to select the People's Choice Award recipient through an online link that we will provide. At that time, we will also invite the audience to submit their questions for our panelists. After our contestants have answered the audience questions, I will then announce the winners. All 7 competitors today will receive at least $300, with the People's Choice second and first place finalists receiving $750, $1,000, and $3,000 respectively. Today's first place winner will go on to represent Berkeley at the UC-wide competition next month on May 5th. Now to our presentations. Our first presentation is from Mara Reed, a fifth-year PhD student in Earth and Planetary Science. Let's play the video.
I both love and study geysers, which are hot springs that can erupt water and steam. Scientists like me study geysers because they can reveal what's going on in underground hot water systems. This has direct implications for things like geothermal power production and mineral exploration. The main question that I think about, what influences the timing between eruptions, is also a central question in volcanology. It turns out that geysers make for pretty good analogs of volcanoes, and since they erupt so much more frequently, geysers are easier to study. My work so far has focused on Steamboat Geyser, which is located in the northern half of Yellowstone National Park. Eruptions there have been occurring days to weeks apart since March 2018, and this is super special because Steamboat is the tallest geyser on our planet. Water ejected during these eruptions can reach a maximum height of 449 feet. That's the same height as the Great Pyramid of Giza, or if you prefer, 1.5 Campaniles. The eruptions are powerful enough to create ground motions that are picked up by a nearby seismometer. When I was looking at that seismic data, I stumbled into a mystery. On average, it appeared that winter eruptions were weaker than those in summer. To show you what I mean, here are recordings of ground motion from 2 example eruptions. The top one is from the month of September, and the bottom one is from the month of February. As you can see, the February eruption has much smaller amplitude, meaning weaker ground motions. The mystery here comes from the fact that people who actually saw the winter eruptions never reported that they seemed weaker during the winter as opposed to summer. So both of these things can't be true. What's going on here? Well, we know that what a seismometer records is impacted by the environmental conditions, but we're still puzzling through which changes are significant. As someone from Minnesota who associates winter with snow, my thoughts immediately went to changing snow depth as a possible culprit. I know that snow can be a really good sound absorber. Let me tell you something about how seismometers work. They're mainly designed to record earthquakes, so motions from the ground. But they can also record loud noises when sound waves impact the ground, like when thunder's rattling your house. Steamboat isn't just a tall geyser, it's a loud geyser. It sounds like a jet engine. I was able to determine that the majority of the seismic signals we were getting from Steamboat came from sound waves. So if snow is the culprit here and softening Steamboat's roar, we would expect lower signal-to-noise ratios as snow depths increased, and in fact, that's exactly what I found. The result means that we should not be using seismic amplitude to directly compare eruption intensities at geysers or at volcanoes if sound waves and snow are involved. It also highlights the need for more long-term monitoring to identify these different types of environmental changes that matter. I'm excited to put more of this monitoring into work as I continue with my PhD.
Thank you, Mara, for that wonderful presentation and for helping us understand more about geysers. I'd like to ask you a few questions so that the audience has the opportunity to get to know you just a bit better. And I'd like to start just by asking you how you became interested in this particular area of research.
When I was a teenager, I went on a trip with my family to Yellowstone, and we realized that there was this small niche community of people called geyser gazers there, and they'd spend, all their free time watching geysers. And I got really enamored with that. So I sort of fell into that community and decided that that's where I wanted to take my studies in graduate school.
I have never heard of a geyser gazer, so thank you for introducing us to a whole other part of tourism in Yellowstone. And now that you've had the opportunity to gaze at geysers as part of your graduate work, what aspect of your work is the most fun for you?
So I'm actually on a fieldwork trip right now, and we get to do our fieldwork in these thermal areas when most of the rest of the public is not allowed into the park. So it's wonderful to have these fieldwork experiences where, it's just you and the geysers and kind of getting to have that special experience of working around them. It's just a wonderful place to be and to work.
Thank you. I imagine Yellowstone must be absolutely beautiful when you're by yourself and paying attention to your research. So thank you so much for sharing your knowledge and for being part of the competition. Our next presentation is from Andrea Anaya Sanchez, who is a third-year PhD student in plant and microbial biology. Let's play the video.
In 2019, over 7 million deaths around the world were due to bacterial infections. That is 1 in 8 of all global deaths were caused by bacteria. Bacteria are very small single-celled organisms that are found almost everywhere around us and have evolved to be able to grow in a wide variety of environments. Most bacteria aren't dangerous, but some are and can make us sick. Bacteria that can cause disease are called pathogens, and there's many different types of them. I am particularly interested in pathogens that can invade and grow inside of human cells, such as Mycobacterium tuberculosis, the bacterium that I study. Mycobacterium tuberculosis, called TB for short, is spread through the air and causes tuberculosis, a very dangerous lung infection that killed 1.6 million people in 2021. Once we breathe TB and it gets inside of our body, it will invade our cells and reside inside of them during the course of infection. This is the point where it becomes a race between our body trying to protect us from the invading bacteria and the bacteria trying to survive and replicate. Fortunately, our cells are very smart and will try to get rid of invading bacteria to protect our body. From previous studies, we know that our cells can exploit different antimicrobial mechanisms to combat infection, such as production of reactive oxygen and nitrogen species, producing antimicrobial peptides and enzymes, or acidifying their phagosome to kill bacteria. My PhD research has discovered a new mechanism that our cells might be exploiting to kill invading bacteria. From experiments that I have done, we observed that when our cells get infected, they increase production of a type of compounds called aldehydes. Aldehydes are very toxic, and we have shown that they can be antibacterial and kill TB in culture. Aldehydes can be easily detoxified by the host, but represent a big threat for bacteria living inside of them. These observations have led to many exciting questions that I'm currently working towards answering. How does the host sense the bacteria and upregulate aldehyde production? Is aldehyde production necessary to control bacterial infection? Have bacteria evolved mechanisms to resist aldehydes made by the host? And spoiler alert, they have. Preliminary experiments have led us to think that some, but not all, intracellular bacteria have evolved to be able to detoxify aldehydes very effectively. And TB is one of them. If true, the discovery of this novel antimicrobial mechanism used by our cells to combat infection could be incredibly exciting. We hope that by studying this bacteria-host interplay during infection, we will be able to better understand the ways our cells respond to bacteria, and maybe even use this knowledge to develop therapeutics that can potentiate this response and kill invading pathogens.
Thank you, Andrea, for presenting your interesting and exciting research. And I was actually personally very interested in it because my daughter was infected by an atypical mycobacterium as a baby. And knowing that maybe we wouldn't have to do all those horrible antibiotics anymore would be lovely. So I really hope that your solution ends up working out. And so I wanted to start, again, to help the audience get to know you a little better by asking you how you got interested in this area of research.
Of course. Well, I'm from Mexico, and infectious diseases are a very important part in Mexico. So I think the clinical part of studying pathogenic bacteria is really important for me. But I also think that bacteria in general just really exciting to study. And I think they're so sophisticated and amazing. And I really love working with bacteria.
Thank you. Well, and my understanding, limited though it may be, is they continually change, right? So you'll have things to study for the rest of your life. What do you find most fun about the work that you're doing?
I think I really enjoy the technical part of it. So being in the lab and doing experiments and, just overall understanding the different mechanisms of bacteria. But I think I also really like the community part of it. So being in a lab with other people and collaborating and just sharing science, I think that's very exciting too.
Thank you. And I think people tend to think about academic life as very solitary. So thank you for reminding us that most scientific work happens in community and that that's actually a big part of what is great about it. So thank you so much, Andrea, for sharing your knowledge with us today. So our third presentation is from Claire Gasquet, a fourth-year PhD student in physics. Let's play the video.
What if I told you that volcanoes can affect the weather in space? Your first question is probably, wait, there's weather in space? Well, up in the ionosphere, about 10 times higher than you'd fly in a plane, the space weather forecast might call for dropping temperatures or blustery winds, just like down here. But up there, the forecast might also include a powerful electrical current or a shower of charged particles. We don't often think about it, but space weather can affect our daily lives. How many of you have used Google Maps? Well, those GPS signals had to pass through the ionosphere, and changes in space weather can distort those signals. We need an accurate space weather forecast in order to pinpoint GPS locations well enough to, for example, land a self-flying plane. And honestly, we still have a long way to go. The future of that kind of technology depends on us improving our understanding of space weather and what drives it. That brings us back to the volcano. Last year, a massive volcano erupted near the island nation of Tonga, sending seismic waves rippling through the earth, launching tsunamis across the Pacific, and driving atmospheric pressure waves around the globe. We found that some of that energy made it into space, where it drove winds to speeds nearly 3 times faster than a Category 5 hurricane. Those are some of the fastest winds we've ever measured in that part of space. But remember, space weather is about more than just the winds. You have to consider the charged particles as well. I found that when those extreme winds pushed on the charged particles, that created electric fields up in space. And then Earth's magnetic field acted like a superhighway, transmitting those electrical signals away from the eruption at more than 1 million miles per hour. Using satellite data, I was able to track the changes in charged particle motions resulting from those electric fields. That's helping me put together the pieces to understand how this eruption took control of space weather on a global scale. But that's not the whole story. You see, several hours before the eruption, there was a geomagnetic storm, meaning a ton of energy and particles from the sun slammed into the Earth. So now we have 2 forces competing for control over the ionosphere. It's like Godzilla versus King Kong, the sun versus the volcano. Which one will win? We found that in this case, the effects of the volcano were stronger. Now, this was a moderate geomagnetic storm and a very strong volcano, so that's not to say a volcano would always win. But what it says is that we have to consider energy down on Earth when we're studying the conditions in space. This event was a case study, which is helping us to improve models of space weather and what drives it. Unlocking these mysteries is essential for us and the future of satellite technology as we push deeper into the space age. Thank you.
Thank you so much, Claire, for a great presentation. I have to admit, I have never thought about weather in space, so I appreciate having the opportunity to learn new things as I do every day in this job. And same with the others, we want to get to know you a little better, so would love to hear what got you interested in this work.
Absolutely, thanks. I've always been interested in math, but it wasn't until I took my first physics course that I found my true passion. In my undergraduate physics courses, I was actually inspired by my undergraduate professor. She was a space physicist studying Earth's radiation belts, and that kind of started my journey in space sciences.
Thank you. It's always nice for us professors to hear we have an impact on people move forward through their lives. What would you say, other than talking about Godzilla and King Kong, is the most fun aspect of your work?
I think there's two aspects to it. There's the discovery aspect, right? We're tackling questions that no one's ever asked and finding out new things. And also just the people that I get to work with. Everyone is so excited about what they do and wanting to share it. And so it's a joy to come to work every day.
Thank you so much, Claire. And
Thank
now
you.
our fourth presentation is from Maisie Wiltshire-Gordon, who is a fourth-year PhD student in rhetoric. Let's play the video.
My favorite mug is pale blue, just bigger than my hand. When the potter was throwing it, she added a smooth ridge that spirals around the cup, and when I hold it, my fingers slide into the grooves. It's very cozy feeling. In the design world, those grooves are what's known as affordances, the features of an object that invite us to engage with it in a certain way. In college, I had a rolling desk chair, and I hated it because every time I sat down, the chair would say, "Roll with me." I study the way that language creates affordances. I focus on novels, which use their structure to shape our relationship to characters, ideas, and experiences. Just as the grooves in a mug invite my fingers, a novel's form invites a certain kind of engagement. Consider point of view. Novels are very good at depicting events alongside what's happening in a character's mind, showing the thoughts and feelings that lead them to act as they do. Sometimes a character describes their own feelings. Other times a narrator gives voice to feelings that the character themselves may not be able to articulate. When novels depict inner lives like this, what are the affordances of that choice? On the one hand, it invites our empathy. When we understand characters' reasoning, it's easier to respond with compassion. When we feel like we know what they're going through, it's easier to feel connected to them. But I see a downside. On this model of relating to one another, our compassion depends on seeing into others' minds. It treats our connection to one another, our responsibility for one another, as a product of our sense that we know what others are going through. But how often do we really know what others are going through? Should we need a direct line to someone's innermost thoughts in order to respond with care and goodwill? I use literary analysis to study the way that novels might respond to this ethical dilemma. For instance, Henry James's The Wings of the Dove blocks our access to characters' minds. Late in the novel, the beautiful Millie is on her deathbed when she finds out the man she's in love with is engaged to someone else. But unexpectedly, she still leaves her inheritance to him. And as readers, we are dying to know why. Did she still love him despite his infidelity? Did she act out of spite to complicate the man's relationship to his fiancée? But James doesn't tell us. You don't get to know, the text is saying. Millie is a private person, and the text demands that we respect that privacy. Literary affordances have ethical weight. James's use of opacity challenges our ways of knowing and relating to one another, asking us to care for others, even without full knowledge of them.
Thank you so much, Maisie, for reminding us how novels really help us understand the human condition. And I'm imagining that perhaps if the academic track doesn't work out for you, maybe marriage counseling might be something that you might think about doing. So as with everyone else, we want to know a little more about you. So how did you become interested in this particular area of research?
I've had the experience of feeling very moved by literature, very engaged in the plots that they describe, and finding that I think differently after I read a novel. And I was just really curious how that works, how it acts on me.
And what would you describe as the most fun part of your work?
I love structuring ideas. taking insights and figuring out how they fit together. Because I think when you assemble the pieces that you've discovered, that's how you actually create new knowledge, is when they're fitting together to make something.
Thank you. And that was a beautiful way of describing, I call it writing epiphanies, when suddenly everything comes together and it just makes sense. And they are rare, but it's what, for me at least, makes the work so enjoyable. So thank you so much.
Imagine, you're a million miles away from Earth on a journey to another planet. You've brought only the essentials with you, because the lighter you are, the quicker and easier you can get there. Then the worst happens. The spaceship that is keeping you alive begins to break down. An important part that filters your air no longer works. What can you do? Well, you could have brought a large amount of spares and backups, but that could be costly and cumbersome. Or you can simply make and repair parts in a matter of minutes. How so? Well, with computed axial lithography, or CAL. CAL is a new type of 3D printing process that has many advantages, such as being self-contained and fast. Additionally, my team tested CAL in a microgravity environment and found that it functioned even better than it would on Earth. I'm going to explain to you how this process works in the same amount of time it would actually take to make a part. We first start with a photopolymer. A photopolymer is a special type of liquid that becomes solid when exposed to a certain wavelength of light. We then take a clear cylindrical glass container, fill it with this liquid, and then seal it. Next, we need to compute the light that is going to be used to form a 3D part. We do so using a mathematical technique similar to a CT scan. In a CT scan, you have a solid object and you rotate a special X-ray camera around it to get 3D data. In CAL, we do the reverse. We start with a 3D model and compute the images it would take to reconstruct this 3D model. After we have these images, we bring them together in a projection video. Once we have our projection video and a clear cylindrical glass container, we can start printing. We rotate our container at a rate corresponding to the projection, and very shortly, our part begins to form. But as the part forms, it can change density, begin to sink or float. But in microgravity, this doesn't happen at all. Additionally, because the light is able to shine through the whole vial, our part essentially forms all at once, very quickly. In fact, the same amount of time I told you how this process works, our part's already formed. But there's a little bit more work we have to do. We want to get rid of all the excess unused liquid. How do we do this? We use a solvent. A solvent is a special chemical that can break down just the liquid and not the solid. After a short wash with the solvent, we're left with just our 3D part. But there's one last step we have to do. When the part first forms, it may not have all the mechanical properties we want. To make sure we have those properties, we need to shine more light onto the part to make it as completely solid as it can be. And then after that, our part is done. We're able to repair a spaceship, and we're on our way back to a new planet.
Thank you so much, Taylor, for teaching us about this incredible new technology. As with everyone else, we would love to get to know you a little better. So if you could please let us know what it is that brought you to this area of research.
Yeah, I've always kind of been fascinated with space, and I kind of always been fascinated with 3D printing, and I found the perfect opportunity here at Berkeley to kind of combine them together.
Out of curiosity, what about space interests you, or which?
I think the challenge of it, I think there's a lot of innovation that happens to kind of push the boundaries of space. And I think a lot of those times, those innovations come back down to Earth as well. So we see a lot of like improvement here on Earth from kind of all the things we do.
And which aspect of your work do you find the most fun?
Yeah, that's a pretty easy question. So for this test, we actually went on a zero gravity flight. So we flew on a special plane that made us feel like zero gravity for 20 seconds. And we did that like 30 times over. That was a very fun experience to float in zero gravity.
That sort of sounds like a science extreme sport.
Yes.
To have the opportunity to engage in. Well, thank you so much, Taylor, for giving us a little bit of insight into your world of space.
Thank you for having me.
And now our sixth presentation is from Madison Brown. She is a fourth-year PhD student in the Behavioral and Systems program in psychology. Let's play the video.
Have you heard that light can help cure Alzheimer's disease? So right now, your brain is taking an external sensory stimuli, like seeing and hearing me in this video, and integrating this information together so that you can understand what I'm saying and form your own opinion. This information is transmitted within the brain via an electrical communication mechanism between brain cells called neurons. In brain circuits responsible for learning and memory, these signals have 40 Hz rhythms. But in individuals with Alzheimer's disease, or AD, this rhythm is disrupted. Thus, new research has looked into restoring synchronous electrical activity and have found that 40 Hz flickering light is sufficient to reduce cognitive decline in mouse models of AD. This seems like there might be an exciting new therapy for humans with Alzheimer's disease, but the problem is that light at this frequency appears like a strobe light. Can you imagine being exposed to a strobe light for a long period of time? Besides general discomfort, strobe light poses potential adverse health effects, like seizures and migraines in susceptible individuals, and this makes it an unlikely target for long-term human usage. So, how do we solve this problem of treatment tolerance? Well, I was interested in optimizing this therapy and worked with photonics specialists to both create and test a novel lighting device that still administers the 40 Hz stimuli to the brain, but bypasses perception of the flicker so that it appears like a regular room light. To test the efficacy of this technology, I took mice expressing an AD gene and exposed them for 1 hour a day to either regular static light for a control, 40 Hz strobe lighting, or our 40 Hz invisible light. After 1 month, I tested for cognition improvements by placing the animals in a pool of water and teaching them how to use environmental cues to find an escape platform. What I saw that is after a week of training, animals treated with both types of 40 Hz stimuli took less time to find the escape, and they remembered where the platform was. This rescued learning and memory ability made me want to look into the brain regions responsible for these behaviors. And when I did, I saw that the same animals that improved on the task have less buildup of toxic amyloid beta plaque, which builds up in AD and disrupts neuronal communication. So because I'm seeing all these factors of improvement, I can tell that our light also sufficiently resynchronizes electrical activity, slows cognitive decline, and reduces buildup of these toxic plaques. I'm next going to look into the biological mechanism explaining the connection between these phenomena. Our light could greatly improve quality of life for those living with Alzheimer's disease and could be placed in nursing homes and have therapeutic potential beyond neurodegeneration. So, although the field of Alzheimer's disease research has been shooting in the dark for a cure for many years, turns out maybe all we needed was light.
Is for many families. And so the idea of having a relatively simple way to perhaps really improve people's quality of life is very exciting. So as with everything else, to get to know you better, could you tell us a little bit about what brought you to this area of research?
Sure. So I've always been interested in animals and how they behave. And in undergrad, I was able to study primate behavior. And I found it really interesting that their behavior and cognition seem to be correlated to their environment and their body physiology. So in graduate school, I wanted to understand the biological connection between the brain and behavior through studying the nervous system. And I became interested in studying disease states and how abnormal states of the brain can actually affect cognition. And then now I'm moving into studying therapies based on that philosophical interest.
That's very exciting, although I'm imagining you didn't imagine it was going to mean playing in pools with mice.
I didn't, but it's quite fun to kind of fall in the pool with them occasionally.
And that was going to be my follow-up question. What is the most fun part of the work that you do?
Falling in the pool is not the most fun part. Besides the obvious answer of getting to look at brains under a microscope, I have really enjoyed mentoring. Getting to share my results with a team of brilliant undergrads has really been a fulfilling experience. And I love being able to like give back to those younger than me and their intellectual curiosity as well.
Thank you so much, Madison, for reminding us. Universities are multi-generational places, and often our best experiences are when we can share our knowledge and our wisdom with those that come behind us. So thank you for doing that, and thank you for your work.
Thank you, Lisa.
Most of Earth is covered in ocean, but we still don't really know what lies underneath the surface. We are developing robotic systems to explore our oceans. These robots need to be able to sample coral from varying depths to better understand and mitigate the effects of climate change. Of the robots in operation today, many are only able to passively monitor and surveil. Current robots lack the dexterity to physically interact with the environment. My PhD research focuses on bridging that gap between robot grippers and human hands, enabling robots to dexterously interact with the real world. My project is inspired by our own hands. Our fingerprints are small ridges on our fingertips, but spend a while in the bath or pool and our fingers will start to prune. Biologists hypothesize that this wrinkling effect is an evolutionary advantage for us to better grasp objects that are wet or submerged. We found this perplexing and wanted to test finger pad patterns on robotic grippers, specifically looking at how to better grasp objects that are slippery due to a surrounding liquid. And so I designed and fabricated finger pads from soft materials with these different surface patterns. Then I set up and conducted experiments to measure the friction forces exerted by each of these finger pads in dry and lubricated conditions. In one experimental setup, I attached the finger pads to a robotic gripper and arm. Results show that a smooth finger pad exhibits high friction in dry conditions and low friction in lubricated. The 3 featured finger pad exhibits high friction in both conditions. This is intuitive that when wet, smooth is slippery, and surface features or treads are generally good to have on car tires and the bottoms of our shoes. However, contact conditions are not typically accounted for. Designing robots for the real world is more than just waterproofing the electronics. We must consider the environment and add surface features for potentially slippery conditions. Designing and deploying dexterous robots are critical in helping us understand our oceans.
Thank you so much, Monica, for sharing your work. And it just makes us think about how complex hands and fingers are and how difficult they must be to replicate. So it's very exciting and I'm sure very challenging. We also want to get get to know you a little bit better. So if you could please let us know how you became interested in this particular area of research.
Yeah, thank you. So I've always been interested in making things, and the area of robotics research I think is super exciting and has a lot of potential for impact. And so, yeah, just building things, and also for robot grippers, a lot of the stuff hasn't been fully studied. So it's really like an open space to kind of test things out. Yeah.
And what do you find the most fun about the work that you do?
So it depends on, what stage of this research process I'm in, of course, but right now I've really enjoyed being in the lab and fabricating or making my systems, and also designing and testing components of the robot.
And I should say, I have two kids that were involved in robotics. I'm sure that the less fun part is when things don't work the way that you're hoping that they might while you're testing things out.
Yeah, it's part of the challenge.
Yeah, but fun when it does, right? Thank you so much, Monica, for being here and for all the great work that you're doing. So my sincere thanks to everyone. I hope this gave you a small taste of how just absolutely incredible our graduate students are here at Berkeley. And now, members of the audience, it is your turn. It is time for you to vote. And while you are voting, you will have the opportunity to ask our brilliant participants any questions that you have about what they presented today. If you could please go to the URL that you can see on the slide that should be visible now. There we go. If you go to grad.berkeley.edu/grad slam, you can vote for the People Choice Award and also submit a question for one of our contestants. If you are viewing this through our website, you can find the links above the live stream. We will now have a 10-minute break to allow you to vote and to write in your questions. So please join us back here promptly at 4:15, and please take the time to vote, and please do ask whatever questions or thoughts you have of our contestants, because they would be happy to answer any concerns or ideas that you might have. Welcome back. Thank you so much for taking the time to vote for our People's Choice winner and for sending us your questions. Now we're going to have the opportunity to ask those questions of our contestants. We're going to do 3 rounds in the order that people presented. And so keep them coming, and hopefully your question will be answered. The first is for Mara Reed, our geyser gazer. She's being asked, given the finding that as models for volcanoes?
Not so much, actually. So volcanoes also can produce this sort of jet noise, both from lava fountaining and from large explosive eruptions. So this is actually a finding that kind of is really applicable to volcanoes, because this sort of sound is being especially those volcanoes that have snow covers to them.
Thank you. The next question is for Andrea. You mentioned that some bacteria have evolved a tolerance for aldehydes. I hope I pronounced that correctly. Could you please share something about these resistant strains?
Yeah, sure. It's not so much that they have become resistant. It's more that I think that some bacteria, because they are evolving so closely inside of the host, they just have learned to detoxify these aldehydes because they have to deal with them every time they infect. And so there's some bacteria that are a lot better at detoxifying these aldehydes. There's some bacteria that are not. TB is actually really good, but there's, like, for example, Francisella, which is another intracellular pathogen, is not as good as detoxifying aldehydes. So I think this mechanism of just like who deals with it better and how they deal with it differently is very interesting.
Thank you. Very interesting. And our next question is for Claire. And it is, what is a geomagnetic storm? And is there a certain intensity of magnitude of volcanic eruption that is considered significant enough to trigger one?
That's a great question. So geomagnetic storms are actually separate from volcanic eruptions. Geomagnetic storms happen when the sun actually spits a bunch of energy and particles in the direction of the Earth. And then you have this collision between these particles from the sun and Earth's magnetic field, and that can trigger a lot of changes in Earth's magnetic field. And so we call it a geomagnetic storm. Volcanoes, on the other hand, can perturb space, like I was talking about in my talk, but we don't have a magnitude set for how that happens. But like I said in my talk, we found that in this case, the effects of the volcano were comparable to that of the geomagnetic storm. So we're still studying that.
And is it rare for these two things to happen at the same time? Is that?
I mean, there's nothing to correlate them together. The sun and the volcanoes are completely separate. So it was kind of a coincidence that they were happening at the same time.
Great. Thank you, Claire.
Thank you.
Our next question is for Maisie. What should we be aware of as readers while reading a novel to alleviate this ethical dilemma you talk about? How do you distinguish between ethics and morality in your research?
So the word morality is related to mores, which means it has a lot in common with social conventions, sort of rules that people follow. And when I'm thinking about ethics, I'm often thinking of something a little more fluid. So thinking of how to respond to a particular situation. So when you're reading a novel, I think it's really valuable to pay attention to the particular situation that's being described there. So less trying to immediately universalize what you see and instead say, what are the specificities of what's happening here and how are the characters engaging with them?
Thank you. Our next question is for Taylor. I would like to know the types of polymers that can be produced using your process, as well as the maximum size and durability of the resulting printed products.
Yeah, so the cool thing about our process is we can actually work with a wide range of materials. So in the zero gravity kind of experiment alone, we dealt with gelatinous materials called hydrogels. We've dealt with really hard materials called acrylates. We dealt with silicones, very stretchy materials. So you can do very exciting things, all the way from repairing parts to printing bioorgans. So there's a lot of crazy things you can do. It's hard to quantify what's kind of the strongest parts you can make. Recently, I actually made a special metal part. So in the end, we were left with a completely solid metallic part.
Great, thank you. It is so amazing to learn the things that we do on this campus. And also, can I just say how impressed I am with our audience that are asking some really specific and difficult questions. And so the next is for Madison. I am curious if there are any behavioral changes in the mice with 40 Hertz strobe exposure to the constant strobe exposure. Did the light therapy stop or slow the cognitive decline of AD? How do treated mice compare to wild type mice in the cognition test?
Right. So one thing that we're seeing is they took significantly less time to find the escape platform on that task that I mentioned. So this suggests that long-term memory is preserved, and there's like a preventative effect of the treatment so far. And then if you're comparing between wild type animals and then Alzheimer's disease mice, you always see worsened cognition as those plaques are building up. So the rescue effect was specifically in our Alzheimer's disease mice.
Great.
I believe that answered every aspect. Yeah.
I think so. I love it. Okay. There are academics in this audience because they're all like two-part questions.
I love it. Yeah.
And then the first question for Monica. Have you looked at the morphology of the tips of the features? And are the ones that you developed inspired by nature?
Yeah, so I second the comment about great questions from the audience. In this study, we didn't look that closely at the particular morphology. I do think that that's a really interesting area of future research. But yeah, for this particular study, we made sure that all those tips were constant across the different surface features, and then kind of called it at that.
I am impressed, Monica, that you have learned the classic academic punt, which is that is a topic for future research. It's true. That's not a criticism, but yeah, it is true. It's always something else to look at. Absolutely. So on to our second round of questions. Mara, we are back to you. And our audience member asks, what is the impact of climate change on this measurement monitoring process?
Well, there's been some exciting recent studies that do show that climate change might impact geysers. On Old Faithful, which is kind of that more famous geyser in Yellowstone that erupts about every 90 minutes, on its center mound, there are actually places where there's wood just in the sinter terraces. So it's petrified wood essentially. And after dating those, some of my colleagues found that they kind of clustered in the same area about the 13th, I believe, century, when there was also a big drought going on. So it's possible that large droughts can sort of cut off water supply needed for geysers to function. So hoping that answers your question.
I'm wondering if they're also thinking about the other side of it, of snowfall. If we have less of it, more of it, more extreme. Some of it just came from Lake Tahoe, more extreme, right? You go from none to way too much. I wonder if that might also be part of what they're asking.
Yeah, at least for recording these kind of ground coupled airwave signals, if there was less snow, it would probably be less of a problem for us because the snow wouldn't vary as much, I suppose.
Thanks. And now we move to Andrea. The question is, would simply increasing aldehyde concentration during infection as a treatment be enough to overcome the TB aldehyde resistance?
I think this is a great question. I think it's a lot more complex than just increasing aldehydes, because it turns out that aldehydes are very detrimental for bacteria, but they also damage DNA. And so DNA damage leads to mutations, and that could be very dangerous when treating a bacteria, right? Because increased mutations could lead to antibiotic resistance and a lot of other things. So I think it's a lot more complex than just, increasing aldehydes and trying to kill the bacteria. I think we really need to understand the mechanism by which the bacteria are dying to be able to harness it and then develop better therapeutics with that.
Thank you, Andrea. Yeah, I think even a layperson like me knows that mutation is usually not a good thing, despite my love of science fiction movies. Our next question is for Claire. They ask, what other Earth events can be considered players in changing quote unquote space weather besides volcanic eruptions?
That's a great question. So one of the things that I actually looked at when I was doing this research on the volcanic eruption was looking back at papers on the effect of nuclear explosions on the ionosphere back from the days when they were testing those. So those can definitely punch the same kind of holes in the ionosphere as we observed with this event. Earthquakes as well can cause that, and also just day-to-day changes. So there's actually tides in the ionosphere, just like there's tides down on Earth.
Super interesting. Thank you.
Thank you.
Maisie is next. Is the idea of affordances strictly limited to novels? Is this frequently used strategically in movie films for character development? And if so, do you have a standing example?
Absolutely. So I think one of the cool things about artworks of all kinds is that the way they're structured shapes the way that we engage with them. So movies are really good at directing our visual gaze, asking us to look at people's faces. The close-up was a really exciting innovation, right? So I guess I don't have a go-to example from film, but there are certainly a lot of cool ways that we're being asked to pay attention through the way that the visual medium is directing our attention.
Thank you. And Taylor, the next question is for you. What was it like flying in zero gravity? Did it make you nauseous?
It was a lot of fun. Yeah, I've been there 3 times now. Each time's an absolute blast. The really cool thing is you get to see everybody else's experiments. So there's experiments from places like NASA, which is very excited to see what they're up to doing, and like other graduate schools and graduate students. So really excited to see that. I did get a little nauseous the last time I was on it. It can be a pretty crazy time. Part of it is you feel 2 times gravity and then no gravity. So you fluctuate back and forth and back and forth.
That does sound uncomfortable. I have to say. Interesting, but uncomfortable. Thank you, Taylor.
Thank you.
Madison, if you are no longer activating the cells that cause migraine, seizures, etc., how does the light work at a cellular level? Sorry, this is a long question. I'm going to keep going.
I'm not going to remember.
What is it actually doing to your cells or neural pathways if the perception of the light is the thing that causes the effects? And then third question, how is that effect being transmitted through the eyes if you can't see it?
Okay, so I'm going to start with the way that the light works. So what we do is we have two slightly different colored white lights that are both flickering at 40 hertz, and they go in perfect antiphase to one another. So it's flickering so fast that your brain can't pick up the actual changes between the flicker. So it still goes through your visual pathway and is propagated from your visual cortex to the learning and memory areas of your brain. So that's our suspected pathway for how it works. So there aren't specific cells in the brain that are responsible for seizures and migraines, but the whole point of the therapy is to try to resynchronize cells throughout the brain and restore that timing. So, yeah.
Great. That was a great job answering.
Okay, we'll see if I got it. Yeah.
Thank you. And next question for Monica. What stage of development are you at with your robot hand gripper design? Texture aside, what is the optimal shape of the gripper, and what kinds of things is it intended to grip?
Okay, I feel like this is also maybe a three-part question.
A three-part question.
So the first part, what stage of design? So this was done in our lab, and so I've actually field tested some of my other robotic designs, and so if you're talking TRL levels, that's like, a couple levels higher. One of the questions was optimal hand shape. I think that's still an open area of research. Recent studies have done more soft, like totally soft, or like adding a lot more soft components to grippers and robotic hands. That's because, if you look at your own hands, they have a lot of soft and flexible parts.
And the last question was, what kinds of things are
what kinds of things? Yeah, so in this particular study, we were looking at grasping smooth and flat objects. The world does not have that many smooth and flat objects around. And so that's why I think we're also interested in these soft hands that can grasp and comply to a variety of object shapes. For now, I've just been focused on things that can fit within robot hands, so smaller objects. I think there's also a lot of really interesting research on grasping big objects and even anchoring onto things.
Thank you, Monica. So we're on our last round of questions, and it looks like people are being kind and they're only asking one at a time. So Mara, this one's for you. What is it like to work with citizen scientists?
It is a lot of fun because it's always nice to see different perspectives. And a lot of my research would not at all be possible without this geyser gazing community. They kind of have this long-standing historical knowledge of geyser features that they've been really kind to share with us. And it's sort of taught me that there is a place for sort of kind of being a naturalist in my work and just sitting down and observing and watching and having that help kind of guide my research process in a way. So yeah, I hope I get to keep doing it.
Thank you, Mara. Our next question is for Andrea. What is the next step for you?
Wow, I think that might be the actually hardest question that they've asked. The only thing that I know is that I do hope to continue doing bacterial pathogenesis science, which I love, and I'm hoping to do it in an academic setting, but we'll see.
Thank you, Andrea. Claire, actually, it's the same question for you. What is the next step for your research?
That's a good question. So in the talk that I had here, I talked a lot about how the volcano created electric fields up in space and transmitted those along the electric field. So that all happened in the first hour or so after the eruption. But the eruption actually had long-lasting effects and affected the ionosphere on a global scale. So in terms of this event, I'm trying to figure out now why the volcano punched a giant hole in the ionosphere that lasted about 13 hours after the eruption. So that's the next step in this research for me.
Thank you, Claire. Maisie, ooh, you got the existential question. How can empathy be found in real life?
I've been thinking a lot about having empathy for others, even as I mentioned in my talk, even without actually knowing everything about them. So I'm interested in sort of acts of attention, where you use the little things that you are noticing while recognizing you haven't understood everything about somebody. But being willing to pay attention and see what you have noticed and respond to whatever it is you're seeing. So trying to show care based on what you've been able to learn, even recognizing that there's so much about people that we don't understand.
Thank you so much, Maisie, for a beautiful answer to a very difficult question. Our next is Taylor. What are the other potential applications of this technology beyond space travel?
Sure. So there's a lot of exciting things. So relating not to space travel, but kind of space itself, there's currently an award that was granted to our kind of sister organization, Lawrence Livermore Labs. They're looking at actually printing organs on the space station and then bringing them back down here for Earth. So that'd be very interesting to see if you get a replacement part kind of printed and then brought back down to you. We're also looking at a lot of different applications for here on Earth just with this process. So like I said, bioprinting is still one of them. We've been able to make very small glass parts. We're looking at making lenses. There's a lot of kind of niche applications that other 3D printers and kind of markets haven't filled yet.
Thank you, Taylor. I'm trying to wrap my head around body parts from space, but that sounds like a movie, but thank you. Madison, for you, in human translation, is this a chronic treatment, or if a patient is taken off the light exposure, will there be a benefit reversal?
We're actually working with a company that's running concurrent human trials, and they're going to run some data analysis on that, on if, you know, they end the trial and there is like a loss effect. But I would assume that this is something we would want people to be on for a long period of time if they are susceptible to disease or they're already having mild cognitive impairment issues. So yeah, I would say long-term treatment.
Thank you. Out of curiosity, would it be something that perhaps you could have in your home and you wouldn't even necessarily know you were being?
Yes, in theory. So we found recently that you don't have to stare directly at it. So it could just be something near your computer or, you know, maybe in the house one day. Yeah, there's kind of a lot of ways this could go. So
thank you. That's exciting.
Yeah, thanks.
And Monica, I'm sorry, your questioner is violating our one question rule. You've got two questions in one. Why do you think the 3 pads worked better than the versions with more? Sorry, you have 3 questions. Why did the 3 pads work better than versions with more?
Okay.
You expect more to be better? And is there any impact on performance if they are convex or concave?
Yeah, so okay. The first question is why we expect 3. So I can't say this with the utmost certainty, but the findings so far indicate that if you have something that's completely smooth, that tends to be low friction, really slippery in these wet environments. And then if you have just like a N plus, like more than one feature, that seems to increase the friction a lot, for example, for the 3 featured finger pads. And then because of the design that we have for these pads, as the number increases, the bending stiffness or like the total stiffness of that finger pad decreases. And so that's, I think, why we're getting the low friction with the finely textured finger pads, because yeah, typically you'd think of them as having higher friction. I forgot the other 2 questions.
Well, you answered the 2 were sort of connected. The last was, is there any impact on performance if they are convex or concave?
The short answer is yes. So for convex or like the ones that go inwards, we've actually recently been doing some studies on, I forget which one, but like the suction cup like ones, we've actually attached some suction cups onto pads that look a lot like these, and have had, friction and also adhesion forces with them. And then for like the rounded features, I think that is more natural to not have those sharp edges. And I think that you could probably have a much more consistent friction behavior. But again, leaving that to future work. Thanks for all your questions.
I'd like to also thank everyone for all their questions and just take a moment to congratulate our contestants for doing an amazing job answering some really difficult questions from the audience and just demonstrating their knowledge. And now we are going to turn to announcing our winners. I have received the judges' decisions and the audience's choice, and want to take a moment to just say you are all winners. You've done amazing work, are doing amazing work. Congratulations on getting to be the 7 finalists for the campus. But I will begin with the People's Choice winner, which I'm very proud to say is Andrea Anaya Sanchez for her work on mycobacteria. Congratulations. And would you like to say a few words?
Thank you so much. I mean, of course, this is always a team effort. So thank you to all of the people that are here supporting me. And of course, to all the finalists, because everyone's research is just phenomenal. And I think it's been amazing to hear from everyone. So thank you very much.
Thank you so much, Andrea. So our second place winner is, we don't have the drum roll, we just have the applause. It's Claire Gasquet from the Department of Physics for her presentation, What Can Volcanoes Teach Us About Space? Congratulations, Claire.
Thank you so much. I'm honored. Thank you so much to everyone at the Space Sciences Lab who helped support me in this work. Thanks to all my friends, family, and my partner for always supporting me. And thanks to you all and the Grad Slam team for making this happen.
Thanks, Claire. And finally, our first place winner and the person who will be our campus Grad Slam champion is Madison Brown from the Department of Psychology, Behavioral Systems, and Neuroscience for her presentation on Alzheimer's.
Thank you so much. Thank you so much. Yeah, I really appreciated this event and everyone that helped me do this research. So thank you so much. I'm excited.
Well, congratulations, Madison. And again, congratulations to you all. You remind us just why the work we do every day in graduate education on Berkeley is so important. And Madison will represent Berkeley at the UC-wide Grad Slam on May 5th and compete against the finalists from the other 9 UC campuses. As we wrap things up, I'd like for us to give a special round of applause to all of our student contestants who are just so amazing and did such a great job today in sharing their research with us. I'd also like to again thank our judges, our keynote speaker, the Advisory Committee on Graduate Student and Postdoctoral Scholar Professional Development, and all the staff members in the Graduate Division, in particular, Linda Van Hunna, who always works so hard every year to make this event possible. Thank you all for coming and joining us for this special event and for all the support you give to graduate education here at Berkeley. Thanks so much.